I want to begin stating some of the obvious. I'm aware that the primary questions that people have involve radioactivity, and I will spend most of my time talking about radioactivity. But I want to begin with the obvious and talk a little bit about the non-radioactive materials that were emitted, because these were overwhelmingly the largest emissions and the ones that have the overwhelmingly the largest effects. So let me begin by stating the obvious, that a fire, any forest fire, converts wood into two products: ash, which stays in the ground, and smoke, which goes into the air. Now, what is in that smoke? Overwhelmingly, the materials in that smoke are hazardous and non-radiologically hazardous. For example, the emissions from the Las Conchas fire were 200,000 tons of carbon monoxide, which is a serious issue. There were 24,000 tons of particulates, 36,000 tons of volatile organic materials. So there were large emissions. Now, this is familiar to all of you because your eyes, your throat tell you about it. The irritation is obvious to all of us. And I know people who have been seriously affected by those emissions. There is one such person in this room, and so that is overwhelmingly the hazard, the effect of the fire. Now, I will be spending most of my time talking about the radioactive materials because I know that's a concern, but relatively those are very small. Let me be more specific. So the next point I want to make is that there are two general sorts of materials. There are materials that are called refractory. Those are the materials that stay in the ash. And there are materials called volatile. Those are the materials that tend to go into the air. For example, it's well known that plutonium is refractory. It almost entirely stays in the ash, whereas polonium is volatile. Now, I want to take this opportunity to point out that there are two words there that sound alike, and I want to clarify that. So I said plutonium and polonium. So polonium is a natural radioactive material that was so named by Marie Curie. Marie Curie named it polonium after her native land, Poland. Plutonium is a different word. It was named after the planet Pluto. So I want to point out that plutonium and polonium are different. However, the radiological hazards of the two are similar. So plutonium may be more famous, but both of them have radiological effects that are similar. Now, there are, turning now to radioactive materials, there are many natural radionuclides, radioactive materials in every forest. And during a fire, many of these are emitted with the smoke, and also many of them remain in the ash, depending on how volatile they are. The materials that are emitted in the smoke include some well-known materials such as carbon-14. Many of you perhaps have heard of carbon-14 dating. So large amounts of carbon-14 get emitted as carbon dioxide. Tritium, natural tritium, as well as tritium that remains from the atmospheric nuclear tests in the 60s, is emitted as water. And especially the largest amounts of the emissions are the radon decay products. So radon is a natural radioactive gas, and the decay products accumulate in the forests over decades, and during a fire, these materials become volatile. Primarily polonium, that was the Poland, that's Marie Curie's native land, Poland. So polonium-210 is is the largest amount that is emitted. And perhaps some of you have heard of polonium-210. It's well known as a constituent of tobacco. So if you, those who smoke tobacco inhale polonium-210, it accumulates in the throat and the lungs and does damage. So there are also much smaller quantities of radionuclides that come from global fallout. Plutonium, that's Pluto, plutonium, americium, cesium-137, and strontium-90. These have been well studied, and so those are also in the forests. And cesium-137 is more volatile than plutonium. There were some emissions too small to measure. We did not succeed in detecting any of those during the fire. Now, the Risk Assessment Corporation, RAC, famous for the word RACER, some of you know the word RACER. So the Risk Assessment Corporation, that's John Till's organization, did a very detailed study of the Cerro Grande fire in 2000 and assessed these materials extensively, took worst case estimates, and concluded that the risk from all of these materials was much less than 1 in a million. The same thing, we saw the same thing during the Las Conchas fire. And let me be more specific as we move forward. So during the Las Conchas fire, we had, we had 90 air samplers deployed during the Las Conchas fire of various sorts. So we had the standard init stations, also the standard New Mexico stations, which Bill will talk about. In addition, we deployed about 20 special samplers of various sorts, both near Los Alamos and regionally. These were operated by 4 different teams. They were analyzed by 2 different labs. So there's a very large amount of data from these measurements. Specifically, at the moment, we have 5,000 measurements in the RACER database. So 5,000 measurements taken from 90 samplers are in the RACER database. That's a large amount of data. I only have a short amount of time to talk about all of those things. So I do have a lot of details. We can talk about the details. For the moment, I want to give a more broad overview of this.